Welcome friends in science lecture first lesson 3 atoms and molecules. In this particular chapter atoms and molecules, as if name is suggesting that we are going to talk in this particular chapter about that atoms, what are basically atoms are and what are basically molecules are. Now right from ancient times we can say that philosophers have been suggesting about these things, that is an unseen matter. So they have talked about unseen matter, and the idea of divisibility was also considered back in India. Around 500 BC, an Indian philosopher Maharishi Kanad postulated that if we go on dividing matter, that is pradarth written in Sanskrit, we shall get smaller and smaller particles. Ultimately, a stage will come where we shall come across the smallest particle beyond which further division will not be possible. So he suggested that we are going to go on dividing a particle and go on dividing. We are going to reach at certain stage where further division will not be possible. So this type of a particle was called as an Parmanu. Right, and from Pradarth to Parmanu was suggested in Sanskrit. That was our literature. Right, another philosopher also, that is Pakudha and Katyama, elaborated this doctrine furthermore. Now getting to another philosophers, that is Democritus and Leucippus, suggested that if we go on dividing matter, a stage will come when a particle obtained cannot be further divided. The same concept was there, that if we go on dividing any particular matter and go on dividing, that we are going to reach at certain stage where we are not able to furthermore division is not possible. So Democritus called these indivisible particle atoms meaning indivisible. So he suggested this word first of all as an atom. So this word atom came from that, right? In our literature it was actually called as an anu from Parmanu. Fine, okay, fine. So these were the elaborated words regarding this. We also furthermore were able to recognize about the difference between elements and compound, and Antony Lavoisier said the foundation of the chemical science, and he gave these laws and all. So getting to new topic, what is an atom is. So what is basically an atom is, so atom, like they have given an example, that what we see in construction work, that is mason, the one who is doing this building work for picking up the bricks and putting cement and doing a construction of walls, that is a construction of buildings of walls. These walls are room and then a collection of rooms to form a building. So they have said that first of all he has to build a walls. From building of walls he can build a room, and building of multiple rooms it will configure into a building. So in the same way the structure of entire substance is depending upon the type of the molecules, and from molecule construction to then atoms. The different types of atoms combine to form a molecule, and from formation of molecules gives rise to a complete structure of that. That is called as a lattice in chemistry. Right, this is about a building block of an ant hill, and these all examples, sand grains and all these examples they have given. So how large is particular an atom is? So in certain way, just to explain it, the size of an atomic radius are in 10 raised to minus 9, that is 1 by 9 is 10 raised to minus 9, that is called as a nano 5, 10 raised to minus 9 in terms of meter, which is nothing but a size of a nanometer. 1 meter is equals to 10 raised to 9. So 1 nanometer will be equals to 10 raised to minus 9 in terms of meter. So you may see the size of the different radiuses, like radius of an hydrogen atom, which is the smallest atom on the earth. Hydrogen, the size is 10 raised to minus 10. That will be still more. You can say it will be 0.1 nanometer. It will be not 1 nanometer also. It's a 10th part of the nanometer, right, which is counted in Armstrong. Water molecule is 10 raised to minus 9. Molecule of hemoglobin, that is a blood hemoglobin that runs inside with your blood, is 10 raised to minus 8 of its size in terms of meter. Grain is 10 raised to minus 4, and ant is 10 raised to minus 3, that is size of an in terms of millimeters. An apple is 10 raised to minus 1, that will be in terms of centimeters. Fine. So definitely size matters, and you may see this picture given by a electron microscope, and this electron microscope have just shown a type of a lattice formation of a structure of silicon molecules. Right? This is a silicon molecules, and this is a structure given by. So you may understand that the size, the atoms, so size is insignificant. That is, then you can't understand the size because it is very, very, very small. That is an entirely a smallest thing present on the earth, as far as we understand as an entire thing. Now we are knowing much more in detail also, but we are not going to go for those topics at present stage of your studies, that subatomic particles and all. We are just going to go up till atoms and just the configuration of simple configuration of atoms. So these are the magnified views of silicon structure, and in modern day symbols of an atoms of the different elements. Just because I cannot go on drawing the different symbols, that's why this time I am taking help of a textbook to directly teach from it. So Dalton was first initial person. He was also a teacher as an chemistry physics teacher, and he worked in schools and colleges at very early stage of his life and prepared these symbols and given a sense of different types of elements in 1800 something odd around, which was a very, very, very early era in which he suggested all these things. Also meant a definite quantity. When he used a symbol of an element, he also meant a definite quantity of an element. That is, one atom of that element. Berzelius suggested that the symbol of an element be made up of 1 or 2 letters of the name of the elements. Like hydrogen, he symbolized as this is round and 1 dot inside. Carbon as an dark black one. Oxygen as an empty. Phosphorus. So this was a structure of phosphorus. He suggested this way. Sulfur 4 formations, S4 likewise, and iron as an I. Copper round and C. Lead round. At that time the number of elements were very less. No, at the type of Dalton the number of elements may be very, very, very less. This is lead. This is silver as S, gold as G, glittering. Platina, that is platinum at present, is P, and mercury as this dot structure. So these are the different symbols. You need to learn this. May be given in the form of an MCQ. You need to identify them. Fine. So So these were the initial stages in which the elements were derived, and the name of these elements were given and the symbols were given. Fine. So like they have given for an example copper as Cyprus, right? The name of the symbol was C. Gold was taken, the letter of English word that was Orium, not given here, means yellow. Later on the IUPAC came, that is an International Union of Pure and Applied Chemistry. So you need to learn this also. What is IUPAC? International Union of Pure and Applied Chemistry. This was an international organization who has approved the different elements, symbols and letters, and the first letter is written always in capital and the second is in lower case. So you may see about with respect to hydrogen, you see hydrogen as a capital letter, only one letter, because there is no other element with H. Aluminium we have A, so A and L as in small letter, not capital. Cobalt is capital C and small o. CO is will be carbon and oxygen. If it is written likewise, it will be carbon monoxide. So you cannot write this. This will be wrong as an format. So these are the format how to write down, like zinc and chlorine. They have given an example, Cl and Zn. In the same way, the Latin words for ferrum. Ferrum is Fe, that is iron. Iron is a common language we are using, right? Iron is a common language, but actually the chemical language is ferrous and ferric. Likewise, we are using the words. And ferrum. Sodium is the name is natrium. That's why the symbol is Na. Sodium is a common word, right? Potassium, that is kalium. The potassium we write down as K. So this is how we have learned the different symbols, and you may see the different symbols and their letters, that is symbolic letters for the particular elements. So Al, argon, barium, boron, bromine, calcium, carbon, and so on. Fine. So these all are the symbols, and you may learn these symbols so that you can refer to the particular elements very finely. Fine. So thank you for this particular video.